In this video, I'm going to show you how we can differentiate and integrate power series. Suppose this power series sigma n from 0 to infinity c sub n times by x minus a to the power of n is f of x. So we suppose the function f of x be equal to this power series. The open form of this power series is c sub 0 plus c sub 1 times x minus a, c sub 2 x minus a squared, and so on. We can find derivative and integral of the function f of x by differentiating or integrating each term of this power series. For finding f prime of x, derivative of f of x, we have to take derivative of general term of this power series. For taking derivative of this expression c sub n times x minus a to the power of n, note that c sub n is coefficient. So in differentiating this term, first we write c sub n. For finding derivative of x minus a to the power of n, we have to use the power rule for derivatives. We bring the power n to the front and we can put n here, n c sub n times c sub n times by x minus a to the power of n minus 1. This is the derivative of this power series. So as you can see, finding derivative of power series is very simple. Just take derivative of general term. Note that because when n starts from 0 in this power series, the first term, as you can see here, is a constant. When we take derivative, that term, derivative of that term is 0. So that term cancels. So here we have to start our series from 1 to the infinity, not from 0. And if we want to write this answer in open form, if we plug in 1 in this expression, we get 1 c sub 1 times x minus a to the power of 1 minus 1. 1 minus 1 is 0 and x minus a to the 0 is 1. So this part is 1. 1 times c sub 1. So all of this is c sub 1. So the first term is c sub 1, which actually you can find that by taking derivative of this term. Derivative of c sub 1 times x minus a is, we have to write the coefficient c sub 1 and we have to take derivative of the bracket. Derivative of x minus a is 1. Note that derivative of x is 1, a is a constant and derivative of that constant is 0. So derivative of the bracket is 1. C sub 1 times 1 is c sub 1. The next term in the derivative is 2c sub 2 times x minus a. The third term in the derivative is c sub 2 times x minus a to the 2, and so on. So for finding derivative of power series, just take derivative of the general term. Take derivative of each term individually. We call this process term by term differentiating. For finding integral of f of x dx, we have to integrate the general term. First we write the sigma. Here the index of the sigma doesn't change and still n starts from 0. For integrating c sub n times x minus a to the n, again note that c sub n is a constant, is coefficient. We write the coefficient and we have to integrate this part. integral of x minus a to the power of n. And for integrating this expression, we have to use the power rule for integrals. Integral is x minus a to the power of n plus 1. We add 1 to the power, and we put the new power in denominator. So integral of x minus a to the power of n is x minus a to the power of n plus 1 over n plus 1. And don't forget to add the constant c in your answer. And this answer in the open form is c sub 0 times x minus a. If you plug in 0 for n here, here, and here, you get this term. If we plug in 1 for n in this expression, we get c sub 1 times x minus a squared over 2, and this continues. Before we do some examples, I should mention that the radius of convergence of this power series doesn't change when we differentiate or integrate a power series. The radius of convergence of derivative of a power series or integral of a power series is the same as the original power series. For example, if the radius of convergence of a power series is 4, the radius of convergence of derivative of that power series or integral of that power series is also 4. But note that although the radius of convergence remains the same when we differentiate or we integrate the power series, this doesn't mean the interval of convergence remains the same. It is possible that the original power series converges at an end point, but the derivative of that power series diverges at that point. But this is not the topic of this video. We'll talk about this in another video. Suppose the function f of x is sigma n from 0 to infinity x plus 1 to the power of n over 2 to the power of n. We want to find derivative of the function f of x and integral of the function f of x. For finding f prime of x, we have to differentiate the general term of this power series. For differentiating x plus 1 to the n over 2 to the n, note that 2 to the n is a coefficient, is a constant. So we write 2 to the n, and we just take derivative of the part that has a variable x. We have to just take derivative of x plus 1 to the power of n. And derivative of x plus 1 to the n based on the power rule is n. We bring the power down and we subtract the power by 1. So derivative is n times x plus 1 to the power of n minus 1. And n starts from 1 to infinity. And the integral of the function f of x is sigma n from 0 to infinity of integral of this expression. For integrating x plus 1 to the n over 2 to the n, again note that 2 to the n is a constant. So we write 2 to the n, and we have to just integrate x plus 1 to the n. And based on the power rule for integrals, we know that integral of x plus 1 to the n is x plus 1 to the power of n plus 1, we have to add 1 to the power, and we have to put the new power in denominator. So in denominator we have to add n plus 1. We have to actually multiply denominator by n plus 1. So the integral of this power series is x plus 1 to the power of n plus 1 over 2 to the n times n plus 1. And don't forget to add c in the end of your answer. Let's do another example. The function f of x is sigma n starts from 1 to infinity 3n minus 4 times by x to the power of n plus 4 over 5 to the power of n times n factorial. We want to find derivative and integral of the function f of x. F prime of x is sigma. Note that when we want to differentiate this expression, 3n minus 4 and all of the denominator are constants. So we write these parts and we just take derivative of x to the n plus 4. And for finding derivative of x to the power of n plus 4, we use the power rule. And derivative is n plus 4 times x to the power of n plus 4 minus 1, which is n plus 3. And n starts from 1 to infinity. And the integral of the function f of x dx is sigma n from 1 to infinity. We have to write the constants first. And we have to integrate only x to the power of n plus 4. From the power rule for integrals, integral of x to the power of n plus 4 is x to the power of n plus 5. We add 1 to the power, n plus 4 becomes n plus 5, and we have to add the new power in denominator. So we have to multiply the denominator by n plus 5. And this is the integral of f of x plus c. The function j of x is given by sigma n from 0 to infinity negative 1 to the power of n times by x to the power of 2n over 2 to the 2n times by n factorial all to the power of 2. We want to find derivative of this function and integral of this function. J prime of x is sigma. First we write the constant, the coefficients, 2 to the 2n times n factorial to the 2. And we have to differentiate only x to the 2n. And derivative of x to the 2n is 2n. We bring the power down and we subtract the power by 1 to the power of 2n minus 1. And from 1 to infinity. And the reason that we have to change the index of the sigma is that the first term of this power series is constant. If we plug in n0 in this power series, we get negative 1 to the 0 x to the 0 over 2 to the power of 2 times 0, 0 times 0 factorial to the 2. X to the 0 is 1, negative 1 to the 0 is 1, 2 to the 0 is 1, and 0 factorial is 1, 1 to the 2 is 1. So the first term is 1. And derivative of 1 is 0. So when we take derivative, the first term, which is a constant, cancels, it gets 0. And so in the j prime of x, we have to start the sigma, the index of the sigma, from 1. And integral of j of x dx is sigma n from 0 to infinity. We write the coefficients first, and we have to integrate x to the 2n. The integral of x to the 2n is x to the 2n plus 1. We add to the power, and we put the new power in denominator. This is the integral of this power series. In this example, the power series of this function is given. The power series of 1 over 1 plus x is 1 minus x plus x2 minus x to the 3 plus x4 minus, and so on. This pattern continues. So the power series of a function is given, and we are asked to differentiate and integrate. Let's start with finding derivative of both sides of this relation. For finding derivative of 1 over 1 plus x, we can use the quotient rule. Based on the quotient rule, derivative of 1 over 1 plus x is derivative of the top 0 times bottom 0 minus derivative of the bottom times top. Derivative of the bottom is 1. Derivative of 1 plus x is 1, because derivative of x is 1 and derivative of 1 is 0. Times top 1 all over the bottom square. So derivative of 1 over 1 plus x is negative 1 over 1 plus x squared. Another way that you can find derivative of 1 over 1 plus x is to write this as 1 plus x to the negative 1 and use the power rule for finding derivative of this expression. Bringing the power down, derivative is negative 1 times 1 plus x to the power of negative 1 minus 1 is negative 2, which you can write this as negative 1 over 1 plus x squared. This is the same answer. And for finding derivative of the right side of this relation, we have to take derivative of each term separately. Derivative of 1 is 0. Derivative of x is 1. Derivative of x2 is 2x. Derivative of negative x3 is negative 3x2. Derivative of x4 is 4x to the 3, and so on. This is how we can differentiate this relation. Now let's integrate both sides of this relation. Integral of 1 over 1 plus x dx equals to integral of 1 minus x plus x2 minus x3, and so on. For integrating this expression, note that derivative of the bottom, derivative of 1 plus x is 1, is in numerator. And so the integral of 1 over 1 plus x is ln of 1 plus x. This is similar to 1 over x. Integral of 1 over x is ln of x, and integral of 1 over 1 plus x is also ln of 1 over 1 plus x. For integrating this expression, we have to integrate term by term. Integral of 1, the first term, is x. Integral of x is x squared over 2. Integral of x2 is x3 over 3. Integral of the next term, x3, is x4 over 4, and this goes forever. And don't forget to add c. But easily we can prove that this constant c is 0. For finding the value of c in this equation, if we put x equals 0 in this equation, in the left side, if we put x 0, we have ln of 1 plus 0, which is ln of 1. And we know that ln of 1 is 0. And in the right side, if we put 0 for x, we have 0 minus 0 squared over 2 plus 0 to the 3 over 3, and so on, plus c. All of these terms are 0. And the left side is also 0, so c is 0. And because c is 0, we get to this relation. And this relation shows that this power series is a representation for the function ln of 1 plus x. I hope by watching this video you have learned how to differentiate or how to integrate power series.